We will be looking at page 449, problem 8.9. This problem refers back to 8.3, so you should take a look at our results from that problem at this time. It says blood types. The count X of children with type O blood amongst 5 children who carries genes for both O and A blood types is binomially distributed with 5 trials and a 0.25 chance of success. So our distribution is binomial with 5 trials and a 0.25 chance for success. They want us to demonstrate using the binomial formula that what is the probability that X equals 3. Well, the binomial probability formula, this formula is on the formula chart, is this. Looks rather intimidating, but it's not too bad. It says the probability that X is equal to K will be n choose K times P to the K power times 1 minus the probability of to the n minus K power. Alright, this formula is written on the formula chart, and more importantly, it can be attained by using the binom PDF function of your calculator, but you will need to know how to use the formula. You may see it in a multiple choice problem. And it's good, in this case, it really does help you understand the binom PDF function. The formula will make sense to us. Alright, so let's define each of these parameters in here. X is simply our binomial variable, our random variable, pardon me. So X is our random variable. And for our particular problem, it is the number of kids with type O blood. Number of kids with type O. K, this lowercase k, even though it doesn't appear there, is the number of successes. Number of successes. In our problem, we're interested in finding the probability of 3 kids. 3 kids with type O. Alright, so K will be 3 in our case. N is our total number of trials. Number of trials. 5 kids total. Thus, N in our case will be 5. N will be 5. And lastly, P is our probability of success. And in our case, the probability of success is 1/4. Alright, so let us now substitute these values into our formula. So, cap P, our random variable X, we want to know what is the chance that X will be K3. N choose K, we call this. 5 is our N, K is 3. This 5 choose 3 here, this portion of the formula is called, come up here with it, this is called the binomial coefficient. We will use the calculator command NCR. N choose K is the binomial coefficient. We will use the calculator command NCR. All this number is, it's going to be an integer. It's going to be a multiplier. It's going to tell us how many ways we can choose this particular situation can come out. If we have 5 kids and 3 of them need to have type O blood, it could be success, 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 fail, fail. It could be success, success, fail, success, fail. It could be several different arrangements. Well, this operation is going to find the number of arrangements. Okay. P is our probability of success. Well, that's 0.25. K is the number that we want, the number of successes, 3. 1 minus P, that is our complement, 0.75. N minus K, this is 0.75, and our number of fails is 2. N minus K, that is 5 minus 3 is 2. So now you can see the formula, and it really makes sense. Here, this is the chance of success. We want 3 successes. This is the chance of fail. We want 2 failures. These 2 will always sum to the total. And this multiplier is going to tell us how many ways that we can make this particular situation. All right, here we go using the calculator. First, I'm going to refer back to question 8.3 and see that we already know what this should be. From 8.3, we know the probability of x being 3 using our calculator function is 0.0879 roughly. All right, that's from 8.3. So let's take a look. Let's again verify this using Binomial PDF, second vars, Binomial PDF. We have 5 total, probability of success a fourth. We want 3. 0.0879 roughly. All right, we want to see now, will this formula yield the same 0.0879? Okay, here we go. We want 5, choose 3. Math, PRB, NCR. This function is called a combination. All right. We first need the total, 5. Math, PRB, NCR. Then 3. That's going to tell us how many ways we can make this particular arrangement. That's 10. Now we need 0.25 to the third power times 0.75 quantity squared. Now we want to multiply this result by that one, so I'll simply hit times 10. And there you see, it's 0.08789, which is exactly what we found previously using the Binomial PDF function. So you can see that the binomial probability formula can be easily had using the Binomial PDF function on the calculator. I'll make one sentence to state our results here. The probability of getting 3 kids with type O blood is approximately 0.0879, roughly 9% chance.